And today we're going to talk about exploring design patterns, okay, for data pipelines. And I call it data pipelines because um, data is now not only in Azure Data Factory, but also in Synapse, right? So I'm going to share my screen, and that way I can start the presentation, and I'm going to stop my video, so hopefully we can save some bandwidth. Again, I really appreciate you spending the evening with me. It's very early morning where I am. I am in the US, and it's very cold. It's about 12 degrees. So I'm going to give you some links to look at later. Right now, this is based upon the Azure Data Factory design patterns. It's my GitHub. So if you go to John Miner 3 community work, you can get everything there. I'll be posting a new one because there's some new information I put here. So I updated the talk. Um, Second thing is, if you're curious what I'm doing, I am a MVP. So if you go here, I don't know why this page is not refreshing, but you can find out what I'm doing. This is my bibliography as well as whatever I'm working on. So I'm usually writing for MS SQL tips or presenting to user groups. These are the different articles that I've written for MS SQL tips. I'm going to focus on three of them that are really good background information. So there is Azure Data Factory parameter-driven pipelines, okay? And we're going to go over the data, there's examples in this talk. We're also going to go over how you can use, the self-hosted integration runtime to do on-premise data sources to the cloud. And we're also going to talk about supporting multiple file formats, okay? Um, this is the actual interface that we're going to get into eventually, but this is the actual Azure Data Factory, right? And we have um, the pipelines here. So, and last but not least, we have a storage container and we have the output. Okay, so everyone is either working today with a data lake or they're working with an ODS, right? And so an ODS is an operational data store in a database. And so let me see if I can do slideshow and make sure I get presentation view on, and then we can talk. So how I'm going to break this down is I'm going to talk for a while on the slides. I need to give you a bunch of background information, and we're going to dive deep into some examples, okay? So again, if you need to reach me, John.Miner@Insight. I work for a company called Insight, and I'm a senior data architect. So technology, terminology, should I say. What we're doing is just moving data. I sometimes call myself a data janitor because, we're moving data from one place to another. But the movement data can be defined with a series of steps, right? And it really hasn't changed. I mean, obviously, the technology of where it's going, is in the cloud, is on premise, has changed. But the ideas behind it, have gotten refined. They're, before we used to run a program, say, let's go back to the days in which I wrote some COBOL, say, at a bank, right? And you'd read up data and you'd write it, right? And you would translate it, you'd make changes to it, right? And that's what we're going to talk about is these pipelines are ETL. Now, when you design a system, you can have systems two types. You can have it tightly coupled or loosely coupled, okay? The problem with a tightly coupled design is that any changes upstream, like the producers, will impact the destination, the consumers, okay? So we don't want tightly coupled systems. We want loosely coupled systems, okay? And with a loosely coupled system design, basically, only small section of the system needs to be redesigned if we're going to change something, okay? So for instance, we're putting data, I'm going to show you the next diagram. It's called a hub and spoke design. So let's, and each of these is spokes, but you can call one on this left side, say a producer. So say we have SAP data here and we're writing it to a hub and we come up with a dimensional model in the hub, and it could be either, a operational data store. So this could be, say, Snowflake, which is a leader in MPP, or Synapse, right? Or it could be Spark, which could be Synapse again, or Databricks, okay? But regardless of whatever technology you're using, you're either using some type of relational database to store your data, or you're trying to use some type of data lake to store your data, okay? And if you had this SAP and you decided, oh, well, SAP is not it's too big for us. We're downsizing. We're going to go to Microsoft Dynamics. As long as you define the customer in your data lake, okay, and most people are using data lakes now the same, that you could replace this as long as you map it correctly. The rest of the system, say a Power BI report, you can meld the data from SAP and Dynamics together, okay? Obviously, it's going to take some work, but that's the idea is that you want to create loosely coupled systems. So let's focus on the data lake because that's where most people are working nowadays, and we're going to talk about how you can write pipelines to work with it. So there are two types of file formats in a data lake. Weekly type file formats can lead to data quality issues, okay? And it can also lead to broken pipelines, okay? So let's talk about a comma separated value file format. The way that works is that each column has some data. You have a comma between the columns, and at the very end, you have a carriage return. Okay. What happens if the columns have carriage returns themselves? Now we've broken a format. And recently, I'm writing an article on wrangling data flows, which is part of ADF, which uses the M language, and I came across that same fact. Okay, it broke. What did I end up using? I ended up using a strongly typed format, okay? And why that's better is because you don't have to worry about such things. So for instance, go back to the CSV file. I have a ID, say social security number, and I'm trying to figure out, hey, is it a number or is it a string? Now, you live in a different part of the world. Your identification number may have alphanumerics in it. Mine in the US only has numbers, okay? So let's say I wanted to know if it was a string or an integer. How would I do it with a CSV file? I have to read up the CSV file, say in Spark, and scan the whole thing to figure out the actual schema. Okay. A better way to do it is Apache file format. Okay. This actually stores everything as binary. It already has the column names, so we don't have to read the first line and parse it into column names. It also has types. Last but not least, it allows for compression and it's splittable, okay? So again, when you actually put things into the data lake, think about the file formats you're using. Stay away from weak type file formats. They're going to cause you problems. Go with strong types. Um, Databricks has been a leader in the Spark area for a while, and the reason why is the founders actually worked at UCLA, and they actually came up with Spark. Okay, so that was one of their PhD theses. About 2 years ago, they came out with something really exciting called the Delta file format. And then what it does is it uses Parquet files plus some logs. Okay, now why do we want to use a Delta file format? We're not going to go over it today, but if you look into it in Databricks, it's very easy to create. One of the things it allows you to do is ACID. So you get the atomic, consistent, independent, and durable transactions, okay? It also gives you snapshot isolation. So you can have readers and writers, but they don't block each other. You can force a schema. So you can say, hey, I don't want schema drift. I always want the same type of schema. Because we're doing logging just like a database, it allows something called time traveling. And again, that's governed by the settings of the Spark engine. So you can tell it how many days that you want to keep. You can also say you didn't want to keep any days. You could vacuum it and get rid of it. Okay. It's an open source format that Databricks did, and it's built for distributed systems as Spark. Let's talk about the data lake itself. Okay. So again, we can see this little icon here is a representation of the Delta file. Okay, and on top of a Delta file format, we can put a Hive table, and a Hive table makes okay the text files or the Parquet files, and again, Parquet is the preferred format, look like a regular table and gives you those ACID properties. You can now select from it, you can insert, and so on. This picture is from Databricks, but we can see that this is an example of Lambda Architect, okay? And Lambda architecture has two concepts. You have a fast lane and you have a slow lane. So slow lane is a batch program. It runs once a day. Say we read from, again, the SAP and we put some data in uh, the bronze, and a lot of times the bronze is called the raw zone. And what we can do is we can write a file there, okay? And that file is the raw data, okay? But say the data needs to be cleaned up. Say like I'm doing Super Bowl, and that's the example I use for the Power Query article I'm writing. In the Super Bowl, at the very end, they have a subscript and then say it's unwanted data. So we need to do some cleanup, right? So what we're going to do is we're going to run a program. It could be a Spark program, could be whatever program language you like to do, that will actually transform the data and bring it to the silver zone. Okay. Now we have something called refined data. Okay. But now say, let's go back to the VentureWorks. Okay. Because VentureWorks is a very popular database example. I'm going to use it today. And say we have a VentureWorks data, and guess what? We want to flatten it to do reporting. Okay. And the reporting is going to be a Power BI. So we might write a program to say, hey, show me all the sales for this month. Last but not least, we could run that program and create data in the gold zone. And a lot of times this is called the zone, okay? Curated data. So again, the architecture for a data lake has the ideas of quality going across. Second thing is we talked about batch maybe once a day, but we can take the batch and actually have it semi-real time or almost real time. So say we run it every 5 minutes. So now the data is more up to date. It's not exactly instantaneous, okay? Last but not least, streaming is the process in which you actually read stuff, and you could use like Event Hub and Stream Analytics to write to the data lake, and that would be real time, okay? So again, that's the parts of the Lambda architect. There's two lanes, a fast and a slow lane, and in the data lake, there's different zones for quality. So when you bring data from whatever system into a data lake, you have to think about two things. What's the size and what's the so that's usually volume, right? And you also have to think about velocity, how fast you have to do it. And that's like the frequency we talked about, right? So when you have a small data set, and that's why I'm going to highlight this word small size data set, you can do a full load. And a full load means you could just drop the target data set and reload, or you can just move it and rename it, archive it, and so on. When you get larger data sets, what you want to do is I don't want to bring 4 terabytes to the cloud every day. I want to bring a small subset. And a subset could be, say, for a given time period, could be a daily update file. And this could be really good for a, small to medium sized data. Not something that's teeny, but, I call small, maybe, several gigabytes or whatever, would be the incremental file. When you get larger data sets, now not only do we have to do incremental, but we really should start thinking about partitioning, okay? Because we're not always looking at the data from, say, we're getting daily sales, okay? And the daily sales is from Amazon.com. That could be really large in size, right? So we would probably want to partition it by day. But even by day, that might be too big, right? So we might want to partition it by the region which it's being sold in, okay? So again, when you use the largest data sets, not only do you want to do incremental loads, but you want to think about how you're going to partition the data for quicker access. Okay, let's talk about Azure Data Factory or pipelines, right? And regardless of whether or not you're talking about Synapse or you're talking about Azure Data Factory, right? They are based upon the same thing. Synapse stole most of the code from Azure Data Factory and it's using similar engine, okay? So it was designed in 2015 is the first instance it popped out, okay, in the summer. And it's considered ELT. And why do we call it ELT? It extracts some data and loads it. And that's done with the copy activity. Last but not least, it does a transform. But were transforms initially part of Azure Data Factory? And the answer is no. Okay. They were actually, you have to use something else. And we'll get into that later. The second version of ADF was released in the summer of 2018. Okay. And this became really popular because it had a ton of connectors. It's used for orchestration, so scheduling, right? I can say copy from on-premise to, the cloud. I can run a job to, say, a Databricks job to clean up the data and so on, right? And it allows you to combine legacy and modern environments. In the fall of 2019, Microsoft was working with Databricks and they said, hey, you know what? What we had on premise was SQL Server integration services. And that allowed us to do this like drag and, configure different transformations. We'd like to have an ETL, and this is wrong. And so extract, translate, and then load, okay? That means we can do the transformations in ADF without having to use a third party to do the compute, such as like SQL Server with stored procedure. So we could copy from on-premise to a staging table and then run a stored procedure. That's one pattern. And another pattern, say, to run something like a Spark engine. Okay. And so this was the first introduction of ETL into the cloud. Okay. Um, Wrangling data flows leverage Power Query. That's popular with Power BI. And nice thing about Power Query is even less complex than trying to do SSIS, okay, or mapping data flows. So let's get at the heart of what most people use, right? Uh, I've written a ton of programs using the ELT um, paradigm, the design paradigm. And we want to talk about design patterns today, okay? So the copy activity is the center of attention using this design pattern, okay? The data is moved from a variety of sources to a variety of destinations. And like I said, we have to use some type of external computing because we don't have it. Okay, ADF naturally did not have it in version 1.2. So both SQL Server, like I said, and Databricks or Spark are popular computing endpoints. Let's talk about the objects and how you draw them and how they're built upon in Azure Data Factory or Synapse. First, you need a link service. What is a link service? It's just basically the connection information on how to connect to a data set. Second thing is, say we set up the connection information to connect to a SQL Server. Okay, great. But there's a lot of things in SQL Server. Am I looking at a view? Am I looking at a table? Am I pulling it? Am I writing it? So on. So we have to create the data set, okay? And the data set defines what we're going to work with. Activities are like the copy activity, store procedure, execute Databricks notebook. Those are things that allow us to do the work, say maybe remove a file. And guess what? Now we combine all these activities with the data sets and we make a pipeline. A pipeline is a unit of work that we can schedule. Nice thing about this is there's not only these, but there's two other things you want to add to your system when you do it. Triggers are used to schedule those pipelines on some type of trigger in some type of schedule, and alerts can be defined to say, hey, if something fails, notify someone. And you always need notification when you design a system because, no one ever writes the best program. I mean, you do as good as you can, but there's always the chance of failure. Okay, let's talk about hybrid data because a lot of people have data on premise as well as in the cloud. And how do we do that? Well, Azure Data Factory under the hood, okay, has something called Service Bus. So when you run a pipeline, it throws a message on Service Bus. Now, Service Bus, okay, where the message goes determines how it runs. So if I say throw it on Service Bus and I'm using an integration runtime that's self-hosted in Azure, okay, it's the auto resolve engine, that it's going to pick it up and it's going to first, you know, compute dispatched activity. So it's going to figure out how to connect to the source and destination, and it's going to do the data movement. Okay. If we go ahead and do it on premise, what we need to do is we need to install a VM. And the VM can be either in your data set and run the data across HTTPS, or it could be on express route and it's more secure because the packets are now on a backbone that don't go across the public internet. Last but not least is that the locationist could be in the cloud, even though it's connected on premise with the express route, and it depends upon what type of peering you're doing, right? So if you're doing private peering, then that means you got a channel from on-premise to this VM here. And so this VM, as long as it's domain joined, you can actually talk to on-premise from the cloud. So there's many different ways to set up a hybrid data movement. I'm going to show you how I did it in my own demo area. Okay, so there is a ton of activities. I just cut and pasted them from the GUI that you can do. The ones that we're going to focus on today are the copy data activity. Okay, that's the most important. Okay, we can also in the future, if you wanted to, do the T, okay, you can do a stored procedure, okay, or you can do a notebook in Databricks. Those are the two popular ones. There's also a Synapse connector that in this state hasn't been updated. Some things that deprecate, and I don't even know if they're around anymore, is USQL. So if you look here, USQL is going away. It's gone away, I think, in 2 years or something like that. You can look up the details. And then HD Insight is being replaced with Spark and Databricks. Okay, so now we're going to get into some demos. So we're going to talk about hard coding versus notebook parameters. We're going to talk about supporting multiple file formats. We're going to talk about supporting on-premise data set with the self-hosted integration runtime. So those are the three objectives. So I have this virtual machine, and this virtual machine is connected to the cloud. And one of our data sets is going to be the VentureWorks Lite, okay, data mart, okay? So we have some data here. We have an address file, we got a customer file, we have products, and you can combine all this into one type of product, but it's, broken down into normal form. And then we have the usual sales header versus sales detail. Now we're going to minimize this and we're going to go to the cloud, okay? And we're going to delete some directories. So these are the directories that we're going to create, and they're in a container. It's a bronze zone, okay? Delete, yes. Okay, so now we have a clear data lake. Okay, let's talk about hard coding pipelines, okay? So this one is going to copy a table to a CSV file. It's very simple, right? So we can look at it, and the thing that I want to point out is what I see most people now do, and it's very important, is first to put the timeout. Its default to 7 days. You don't want that. You want to set it to a time that is reasonable, right? So I'm going to say copy a small file in 5 minutes. That's probably even too much. We can also say how many times you want to retry the pipeline before it really fails, right? So it could give you a failure, but maybe we have problems in certain time of day doing something. We say, hey, do one retry and it suddenly works. Now, when you do the copy, there's two things you need to worry about. You need to worry about a source, okay? And you need to worry about a destination. They call it a sink, okay? So let's look at the asql AdventureWorks Lite, right? So we're going to go into data sets, okay? And we see the asql Lite. And so we can see it's defined and it's hard coded right now to a table. There's no parameters, so it's not parameter driven, it's hard coded. And if we look at the asql, link service, and again, you can see I'm using notations, right? PL for pipeline, DS for data set, and LS for link service. If we go to managed, okay, we can see link services, we can see where things are going, right? So if we look at this AdventureWorks Lite, we can see that it's actually going to a cloud database, okay? And that's one type of data source. We're also going to work in later on an example to show you how on-premise works with that VM I showed you. And that VM is connected to a runtime, okay? And that runtime is pointing to that same server. It happens to be that I put the self-hosted integration runtime on the same database server. It doesn't have to be that way. It's also parameterized. We can give it a database name. And we have some credentials here. And the credentials, when you set up credentials and there's a possibility that you can't do like a managed identity, which is like a service account that Azure's actually maintaining, then what you want to do is you want to actually use your username and password, but you don't want to worry about having to change the information every time it changes. And say if you got a bunch of connectors or a bunch of systems that are using this information, so a better way to do it is to use Key Vault. So Key Vault's being used in this design too. Okay, so now that we have the data sets, right, we could go back. One thing I always love doing is testing it, right? It says, hey, I do have connectivity. If we hit the preview, we get some data, okay? So let's talk about the copy. What's wrong with this one? First is that right here, we're not even specifying it. So it's not dynamic. You can't suddenly say, hey, use another source or destination. Second thing is, guess what? It's hard coded where it's going. It's going to go in bronze design one, so design pattern one, sales LT, and we're just going to drop an address file. Okay. So if we go over here and we run it, we hit debug, it's going to spin it up. We can see that it's going to look for a self-hosted auto-resolved. So let's get this right. Auto-resolved engine to run on it. And hopefully we can find some compute. See the auto resolves showed you that ran under it, ran US East 2. There's always a pipeline run ID, okay? And we can see that it's successful. And one of the things that I always like doing is that everything in Azure Data Factory is a JSON message. So we can look and we can see that, hey, you know, we're doing a tabular transfer translator, and I have a whole article on that in which you can do dynamic mappings. But we're not actually mapping any data. It's just saying, hey, read from one place, write to another, and adhere to whatever data types we have, right? And if we're interested, we can do output. It tells us how many rows written, how many read, right? Files written, if it was parallelized, how long it took, the throughput, all that fun stuff. And then if you're curious, you get a graphical picture of the same data, okay? So let's take in the data lake. So if we hit refresh, again, storage count, and the storage count is a storage container, and I got a bunch of directories, but in the bronze zone, right, we look at design one, we can see is the sales light model, and we get an address file. Okay, let's talk about issues. First issue is this can get quite unwieldy, right? Because we have a ton of files. Second thing is we're not actually keeping track of versions, right? And we might want to keep track of versions. So let's try to fix that in the next design pattern. So next design pattern is we're going to actually use some parameters, okay? So this design pattern, we were going to pass in the schema name. We're going to pass in the table name. We're also going to give it a zone, so bronze zone plus a directory. We're also going to tell it a file type, okay? So now if we go to the source, we can see now this is using the same connector, but we're actually using the expression language to come up with dynamic SQL. We're saying basically select star from the schema dot table name, and it's more dynamic, okay? Let's talk about sync. Same thing. The directory name is the zone name plus the schema name, and then the pipeline name is the table name. Now, what was wrong with this? This was hard coded and it's only good for one table, right? If we had to do a second table, we have to change adapt to make a copy of it. We have to change the location, hard code it again. Well, this version now I can go ahead and I can make multiple calls to it, okay? So I want to copy over, okay, the address. So now you can see execute pipeline copy address. I can do the same call, but do customer, so on. So now if we execute this, we're going to bring over a ton of data. We hit refresh. Now, let's talk about parallelism. We can see that how's this going to execute? We have these execute pipelines. So this one, because there's a precedent between this one, and you can say on failure, on success, right? It's going to say we have to finish executing this before we execute this, okay? So if we hit refresh, okay, we can see that we have two streams in parallel running. So one of the things you have to worry about is the compute, especially if you're on self-hosted, because there's only so many threads you can run these on. And that's probably a whole different talk on how to optimize that. But I chose two, knowing that it wouldn't overwhelm anything in the cloud and it's small data and it'll eventually get done. We can see that the bubbles are going here with green, so we're going down, the two are executing. And so if we count 1, 2, 3, 4, 5, we probably were dropping 10 tables, I think. And so now we go back to the data lake. We go up one, we hit refresh, and we go design, sales LT. Hey, this is a better design now. So before we had everything in one place, but we couldn't easily find it. Now we have a directory per each one. Not only that, it has a timestamp on it, right? So we can always look at the most recent file. One of the things I'm going to do is I'm going to run this one more time. Okay. And hit refresh. And I'm going to talk about a problem that I didn't solve here, but I'm going to let you play with. The nice thing about the current one is it's doing the timestamps, okay? And it's using, whoops, wrong button. Sorry. Let's go here. But look at this. There's two things that I see problems with. First is that if we went into this directory, how do we know what's the most recent one, right? We're doing a full copy, okay? So we're not doing incrementals here. And I'm not going to get into incrementals today, but it's an easy pattern to solve. But one problem we have is now duplication of data, right? So how do we know what's the most recent file? One way to do it is we could just move this to an archive directory, leave this as the top one, and have our code and Databricks just pick up the topmost one and create a table out of it, right? A delta table. So that's one thing to look about. Second thing is we're only using a CSV file. We talked about CSV files being fragile. So how are we going to fix that? Okay, so we're going to go to the next design pattern. Okay, the next design pattern, okay, and again, is actually going to do if-then connections. So if-then is a design conditional pattern, right? It allows us to say, hey, if I say do delimited, right, then guess what? I can drop a delimited file there. If I say, hey, I want parquet, I can do parquet. Now, does this magically do it? No, it doesn't. But no, what we need to do is we need to put a if-then statement in for each of the file formats we want to allow for. So I'm going to allow for delimited. And I also, it could be, if I delimit it, I could change the extension to txt. So now I'm adding more parameters. And it could be not just a comma, but pipe, right? So I could put a pipe delimit, okay? We also can do Avro, awk, which is a different file format compared to Parquet. It could be JSON too. So there's certain formats that, and I think I saw Parquet somewhere. So delimited, JSON, Avro, Parquet. There we go. So we have one example here. Let's just run it and let's talk about what's wrong with it, okay? Okay. Wow, that's interesting. Did we see what happened? Well, we ran everything, but because we do not know which one we're going to actually execute, right? It has to evaluate all the if-then connections. Not much extra overhead, but there is some overhead because we have to say, hey, is it an Avro? No. Is it an awk? No. Is it a Parquet? No. Is it a delimited? Yes. And then write it, or is it a JSON, right? Now, if we go back to the directory, right, and go up one and hit refresh, we have design, sales SG directory, we can see a CSV file showed up. Okay, that's great. How about if I want to change it? Well, is that really hard to do? Not really with this design pattern. So now we knew that Parquet is there. And how does the underneath work, right? So let's pick Parquet, good strong. And what's going is, if you look at this, it's looking for the word Parquet. So I'm going to copy this, and it says to upper. So it's going to take whatever we pass to it and make it upper. So now I'm going to change this to Parquet. And I want the extension to be lowercase because I thought everything was there lowercase. And you know what? This doesn't really need to be there. Okay. And so I could just put a space there to say, hey, make sure it doesn't blow up. And now I'm going to run this. So again, we have the same pattern, which it skipped all these, and now it hits the Parquet, right? We can see it's picking up the right one, which is great. And if we hit refresh, it finishes. If we go here and hit a refresh in the directory, we get a Parquet file, okay? So now we're supporting multiple file formats. Not the best way though, okay? So we'll keep on, you can see each of these patterns is getting better and better, right? So close and discharge. Okay, let's talk about how do we work with on-premise data, okay? So what we're gonna do is we're gonna do on-premise data, okay? What's a better way to do it? Well, um, there's two refinements we want to do. First is because last time we did if statement, we have to evaluate each and every if statement to figure out what we're doing. If we use a switch, it's automatically going to look at the actual tag that we bring in. That switch statement says, hey, this is the value that I want to switch on, and it's going to find the case we want. So guess what? It's going to run better because we don't have to do those additional ifs. It's going to run one activity. Second thing is that we can see that if we go back to here and go to parameters, right? This one, we can see that there's a lot of stuff here. But say I want to support the tabular translator, which is a mapping document. Well, I have to add another parameter. Then I want to say support, I don't know, whatever format. I keep on adding parameters. We can see this gets quite lengthy, and we can get really confused quickly, and it's hard to, understand what's going on here if we keep on adding parameters. A better way to do this, okay, is to actually use a dictionary and JSON, basically a JSON document. So JSON document is a key value peer, and we can see now that I can go ahead and say, hey, do VentureWorks, LT, address, zones bronze, right? And again, in our example, we'd want to change this to like design 3. And then this is doing a ORC. We could do say a parquet, right? And then another parquet. And now, guess what? Instead of passing a ton of parameters, there's a little setup on our side in which we have to put this into basically a document. Now, you can see readily that the next step would probably be putting this into a table and doing a for loop with some conditions, okay? And that's called table driven, okay? Design, debug. So we're going to kick this off. Hopefully I didn't make a mistake on the document. That's the only place I could make a mistake. Now we can see it did a switch. It's small enough to say, hey, I want to do a copy to Parquet. It's running the command that's inside the switch on the actual case that was hidden. And this one's taking a little longer, so maybe things is, oh, why is this taking longer? Well, guess what? It's not in the cloud. This is actually going self-hosted integration runtime. So it's pulling from on-premise or pseudo on-premise data. Let's look at output. If we go back to Bronze Zone, we can see design pattern 3's there. We have the directory for sales, address, and guess what? We got a Parquet file. So let's talk about how do you set up, okay, the self-hosted integration runtime. I'm going to go back in Azure Data Factory, went too far out, and we're going to go all the way down to manage and talk about it. And then we'll go to the self-hosted VM. So what is a self-hosted runtime? A self-hosted runtime, integration runtime, is just basically a VM that you install some software. So when you do it, you have to install a download from Microsoft, install it on there, and use a key. Once you set the key up, and if there is an access, there's some, ports that need to be opened, such as, for traffics, like port 80, and I don't know the rest of them. I assume it's probably maybe 443, but you can look it up. Um, Once those ports are open, it will send HTTPS traffic over the either public internet or the private if you're using ExpressRoute. But this is the piece of software that you need to configure. Okay. And like I said, I put this software on the same box as my database. Okay. So this is a VM for SQL 19, and it's pointing to my Azure Data Factory for tips. I write for SQL's. I'm a SQL tip, so that's why that's there. And we can go into the database. So this is the cloud database, but we can see the local database. So we're going to go to VentureWorks tables, and we saw it took some more time because not only did it have to put the message out there, but then the software on the VM had to recognize the message there, read it, get the security, get the credentials to execute against SQL Server on-premise, get the data, push it back to the cloud, okay? But we have the same schema here in on-premise version as in the cloud. Maybe the database name is just a little different, but we have the same data, okay? So I talked about the integration runtime. I talked about on-premise data. Is there anything I'm missing? Don't think I am. One of the things you can do, and I want to show you, is that high availability. Say if you wanted to make sure that your system doesn't go down, you might want to put 2 of these up there. You can also see concurrent jobs. This is where you get CPU and you can bring it up. Also, you want to make sure that you have accelerated networking done on your VM. Okay. So let's go to the last pattern. So we talked about so far this, right? And we're actually copying data. And we ran this once. How is this going to on-premise? Well, we talked about the link service, so we're going to go back to here. And we can see that MS SQL VM 19. How was that set up? Well, instead of doing the auto-resolve, we picked the shire, which is the self-hosted integration runtime, and we passed the right credentials. That's all we had to do. And for the adapter, okay, when we create a data set, we just have to find it, and it's right here. And we can see now that we did, that's not the right one. It might just be this one. Nope, that's the storage. Right here. And so we can see this one is actually going to the link service, and then we parameterized it. So we got some parameters. We got the actual data set name here, and this is hard coded. Okay, and the last one, did I go ahead? How did we do this? Just want to double check. Source, so database query, database name. Okay, so even though there's a little trick you can do, is that even though this one is actually saying that's a table, and we could parameterize a table, when we actually do the copy, what we can say is we're going to overwrite it with a query, and that's what we did. And so in there, we're actually um, getting a string of the parameters of the metadata, right? Dot. So we do JSON of the string of the metadata schema names, right? And then we have to do the same thing for the table name, and then we concatenate it with the select, and we get the right select statement. Okay. So the last one is this one, in which we're going to go back and run it. And then I'm going to get back to the slide deck because I'm running out of time. We started a little late. So um, we talked about this is the pattern that allows you to pick multiple files, and it's going to read from on-premise to the cloud. This one now is a little different. This does the big data from admin mechanics. So we got a big product data and we got big product history. So we have three pipelines, and the calls are just a little different. We're going to call this new pipeline with the correct parameters. So I'm going to kick that off. Okay, we'll come back to wrap up our discussion. So we got the pipelines. We're not going to have time to do the demos. If it was like a user group and I had a few more minutes, I'd do the demos for uh, ETL. Okay, so let's talk about the pros and cons of ELT. That's what we did. Most all components can be parameterized, so we saw that. So we can have like a master pipeline, like that one component, and then we can have a call to it, a generic pipeline. We can see that eventually this is going to get to a table-driven design in which everything can be put in a table, and that can drive our ETL. And that's smarter because now we have less components. We don't have to worry about calling them, and we can do scheduling many different ways. Okay. So with the ELT, transformations have to be done with either in the database with stored procedures or notebooks. And the notebooks could be any flavor of Spark, right? And it's going to be a data lake. Things you want to think about. Execution of multiple pipelines in parallel to reduce the overall transfer times, right? Um, we can also change the batch size in SQL. So how much do we send to the database before we commit? Or the cluster size in Spark, which is how many nodes we're going to use to work on the data and how we're going to partition that Parquet file to alter the execution performance and overall timing. So those are things to think about, and those are kind of like advanced topics. Let's talk about ETL, okay? And this is the other one that we're not going to have time to go into, but I'm going to talk about. The source and destination have to be in the cloud because the mapping data flow or the wrangling data flow is using the Spark engine, and it's using the Databricks Spark engine. I don't know if they've changed that over to Microsoft Spark engine, but that's what's being used. Um, there are parameters support for data flows, but the problem is you cannot have a dynamic destination because it looks for schema drift. And because of that, we can't do the fun stuff we saw in the previous one. We have to kind of custom code a lot of things, okay? There's 16 additional transformations in a mapping data flow that allows you to do the T. Wrangling data flows started in 2 years ago as a release and then recently came out. It's based upon the Power Query interface in M language. I like it. The problem right now is limited source types that are supported. Second thing is that the interface allows you to do some things that will not run on their Spark engine. Okay, it doesn't translate the M language correctly, and so if you know those limitations, you can use it. I'm looking forward to the product group fixing that product so it's ready for prime time. So let's look at the extract, translate, and load components. Now we have a lot of stuff that's kind of like when you looked at SSIS. We can take two data sets and join them. We can do a conditional split. That means take the data and split into two pipelines. And we can union data. We can look up data. We can add things like derived columns, okay, selects, aggregates, so on. And there's some other things like the source sync and new branch that are not part of this component. So let's go into the pros and cons of using this, okay? Uh, Regardless of whether or not you're using a mapping data flow or you're using a wrangling data flow, which is the M language, you still have to use a standard pipeline. You still have to define that source data set. You still have to define that destination data set. There's some other options that you have to worry about when working with Spark, like partitioning, batch size, isolation level, okay? Nothing you have to worry about is it does take time for the Spark cluster to spin up. Now, they fixed this, but one of the things you want to make sure is that there's a time to live. So once it's spun up, you might want to say, hey, I want to keep that Databricks cluster around for an hour before it shuts down. Because otherwise, each time you run a mapping data flow, you have to wait 5 minutes for the cluster to spin up. Another thing is there's overhead to parallelism of a data stream. So when you do the copy activity, okay, it might be better than a data flow for small data sets. Okay, advanced lookup and transformation steps can be performed with data flows, which is cool. Again, let's do a cost comparison, right? A quick estimate. So last time I looked, and again, this is a while, you could redo it. I mean, there's a costing engine out there. Uh, I don't didn't do the cost of a virtual machine, which is a couple $100 a month with the integration runtime. And if it's on premise, then you don't even have to worry about that because you're already in your data center. But on average, it costs about $262 per month to run ADF. In Spark, guess what? If you're using data flows, you're adding an extra 1,500, 2,000 per month. So that's a consideration. Um, I might have, if we have, we'll go back to this. I want to wrap up the slides. Look at maybe a Wrangling data flow. It's something I'm writing about. I can go quickly through it and then call it a day. Summary, okay? Azure Data Factory supports two design params. You can have ETL and ELT, right? ELT is the pipelines, activities, data sets, and link services. Basically, at the heart of it is the copy activity, okay? The cool thing is you have a multiple tude of sources and destinations you can do, okay? And the computing has to be done with an RDBMS, with a stored procedure, or with a Spark. Uh, Recently, Microsoft, within the last 2 years, added Databricks slash mapping data flows and wrangling data flows to the design. So now we can do the T. Again, there's a bunch of transformations you can do, and then there's a end destination. So is there any right way or wrong way to create these processes? And what I want you to do is ask these following questions. Does the process accurately perform the data movement and translation of the data? If it does, then you've solved it, right? Does the process execute in a reasonable amount of time so the data gets there so the business line can use it? That's another question. And if it does, then you solved your problem. Some processes can scale, right? So if you think your business is going to suddenly go from 0 to 1 million miles an hour, then does the process scale? And again, that's something that you have to define as a success criteria. And last but not least, does it meet your operating budget, right? So in summary, Data Factory offers many different ways as a developer to move and transform data. At the end of this slide deck, there's a bunch of things. Naming conventions are very important. I use N. Navin's WordPress document. He came up with something really good, and I use those. Pipelines, mapping, wrangling, and integration runtime, okay? So thank you for your time. I have 4 minutes, and I'm going to open up to any questions.
Uh, Actually, John, we are broadcasting this event through Facebook.
Yep.
So still, currently we cannot take any question.
Okay.
Um, but it is quite interesting, and I feel it will be very much helpful for the audience. And uh, personally, I am working on local ETL process, but I think we need to use data factory, but in customer side, it will be it will be they are thinking about the concurrently the expense uh, say Azure. What about the? I think I have a question in my mind that how much money will be recurrently they have to expense, say
Yep.
in a mid-size company.
Yeah. So like I said, the ADF, if you're using
Yeah.
Azure Data Factory itself, it's the lowest cost that you can get. But then you have to do the transformation somewhere else, right? So if you're going to that ODS, which is a database, then you can do that with stored procedures, and that's part of the database cost, and you already have that cost figured out. If you're not going that, then you can go with Databricks. And one of the things nice about Databricks is that you can tell it how long you want the cluster to stay up, right? So you run all your jobs and the cluster goes down. So you're not spending money for that compute, right? You're doing the same thing with Azure Data Factory or Synapse, but I think, like I said, I think the clusters nowadays stay up an hour so that you don't get that down and up thing because it does take 5 minutes to start it up. But again, you can worry about that by doing concurrent. And, again, you can write a big job in Databricks to do all your transformations all at once if you have that ability. A lot of times people want to do things in chunks and schedule it. And so this design pattern of like, hey, copy data and then call either the stored procedure or the Databricks falls into that paradigm, and it's really good.
Okay. Thank you.
You're welcome. Hey, do I have 2 minutes or is the next speaker here?
No, you can, if you want to say
Oh, please go
any
ahead.
hot topics within 2 minutes, you can, you
Okay,
can say.
so awesome. So I wanted to show you 2 minutes what the mapping data flow, wrangling data flows look like.
Okay.
So, and it's an article I'm writing. You'll see it on MS SQL Tips pretty soon. So, how many people are in the US? A lot of people like Super Bowl, right? And so the Super Bowl's coming up. And so let's go to Wikipedia. I'm a Super Bowl fan and I want to go to Wikipedia. I'm going to type Super Bowl. Okay. So I'm such a fan. I want this data in my database for some reason. Okay. And again, this is a contrived example, but we can see there's some serious issues here. There's carriage returns, right? There's a lot of extra characters we do not want. And say I'm a citizen developer in which I know how to use Power Query. How can I do the same thing that we're doing here? Well, if we go back here, okay, what we're going to do is we're going to do the final one, okay? And again, do not use CSVs with these because if there's that bad data, you're going to have problems. So what we're going to do is we're first going to take the source, okay, which is the web page. And again, the article will explain all of it and drop it to a Parquet file. Okay. Second thing is the destination because Spark always writes a bunch of files. Okay. We really can't tell it a file. We're going to tell it a directory, but to clean up and make sure we don't get duplicated data, we have to clean out the directory. So that's what the delete's used for. This is actually the transformation here. So what I want to do is just show you real quickly what Power Query looks like. And so Power Query looks like, and I'm going to see if I can minimize this. It looks exactly like if you were doing Power BI. And it might take a little while to spin up, depending on if it's awake today, like I am. I need some more coffee. So one thing I want to point out right here is not all the functions are available. So if we did some functions that uh, like if we took it and we split it on this delimiter right here, it's not going to work, okay? Now, no, what I do is I know a lot about the back end. I like writing code, okay? So what I did is I wrote all this in my own script, and that's why I renamed the steps here. Usually I don't see step 1, 2, 3, right? So we can go to Advanced Editor. And advanced editor is, hey, we're going to read that Parquet file and we're going to get rid of anything that, is not to be determined. Now, the M language is functional, so we have to create like almost like a f of x, right? And that's what it is. Let all these, and it's built upon. So source is the destination. And then step one's built on source. And then step two is built on step one. So we're going to replace text. And then we're going to replace the 50, which is wrong character with an L because they're supposed to be Roman numerals and they made issues. And more carriage returns. And then, we're going to go ahead and we go text position of a certain delimiter, which is the parenthesis, and we're going to get rid of it. So we're going to do truncation and so on. The main thing I want to show you is that this is the data before, okay? And then if we go to the last step, okay? And hopefully it's slow today. This actually runs on a Spark cluster, so it's still some online service, so it's thinking right now. Eventually, it's going to come up with the answer. And while that's working, I'm just going to go back to, did I get rid of it? Where is it? I did get rid of it. Dashboard. I want to show you the output. Storage count. And open Explorer. Containers here. And then if we go into bronze, this is where we're going last time. So remember we did the DBO with the big product and we have the Parquet files. Okay, so that's that example. And then this one I think is under tips, under bronze and Super Bowl. And we can see we can do both the Parquet and a CSV. We can come back and we can see, guess what? It cleaned it all up. Remember, we had all this junk. Now we have it all. And if we did run it, and I'm not going to do that here because we're basically out of time, the destination is basically a SQL table, right? And so with this design pattern, you have to use, if it's a weird data source, like if it's not a RDBMS or a Synapse, you have to use the data lake as a between place to place the data, okay? So if we go back to the VM, I can show you the end result. And basically I did get my Super Bowl data, it's in there. So I think I put it in the cloud. And so if we do this guy, 22, come on. Problem with Azure SQL databases when they're like DTU 0, they seem to take forever. And I think this is a basic one. And so if this expands, you'll see my Super Bowl table and eventually the data will be there. So anyways, some exciting stuff. If you like Power Query, you know, there's definitely some exciting stuff coming down the road with Microsoft. So Ashan, I want to thank you again for having me. I really appreciate you inviting me to talk today, and I'm gonna probably go back to bed. It's a little early here. Maybe have breakfast.
So, John, you mentioned before you started that in the place where you are, it's 12 degrees, correct?
Yes.
Okay, so let me just share my screen.
Is it snowing?
Well, let me just say that here in Portugal, it's also 12 degrees. The difference is it's 12 degrees Celsius, so it's a reasonable temperature, completely freezing for Portugal, but still, you know, reasonable for the winter. In the summer, it's obviously much more.
I'm
But in
still
any
looking for
case,
your background. It's not coming through. Is it coming through? Maybe it's
uh,
me.
I'm not sure. It should be. Can anyone else see it? I'm not sure. Do you see my kitchen or my background?
I see you in a background screen behind you. So
Okay, perfect, perfect. Okay. Okay, so anyway, just before my cat complains, here's my cat. Because my cat usually likes to go to Azure sessions. But anyway, this is always a very truly global experience. So, John, you are in the United States. I'm somewhere in the westernmost point of Europe, and of course, everyone else is in Bangladesh, somewhere in Asia, of course, somewhere in the middle of Asia. So it's literally all over the world that we've been doing this, especially since the pandemic.
Right.
Okay, so should I start?
Sure.
go for it.
Okay,
But
so
before
John,
that, I want to thank John, and uh, he is very much early morning and winter cannot. We are very much thankful, John, and hopefully your topic is very much interesting. And personally, got I got I have I have helpful from this session, and hopefully the audience will be also very much uh, thanks for your
Excellent.
session.
No problem. And if you reach out to me if you have any questions. And Andre, I'm speaking in Stockholm. Hopefully, I put in, so I hope it's live. Maybe we can see each other.
okay, I
Okay,
definitely hope
sure.
so. Let's see what happens.
Take care. Bye.
Okay. Anyway, I also want to
thanks everyone. We are going to move on the next session. And then can you please start your session?
Okay, thank you. So I also actually want to thank John because John actually did a session on mostly ETL processes, etc. And next we're going to talk about machine learning. And machine learning, one of the most important things to do machine learning is to get good ETL processes and get all of the correct data before doing machine learning. So if you want to have success at doing machine learning, a major percentage of this, 50%, 60%, whatever number you want to make up, it's going to be about doing the ETL process of preparing all of the data before you actually feed it to the training, to the machine learning training. So that's the most important part. And John was actually showing Azure Data Factory. I will show you a list of all of the tools that are available. One of them is going to be Synapse Analytics. We're not going to talk much about it today, but Synapse Analytics also has inside of it the equivalent of Azure Data Factory. So you can put everything in the same environment. So you can do the same things you saw for Azure Data Factory. You can do also machine learning. You can do other processes as well all together inside. You can even do Power BI inside of Synapse. Okay. Although this is not our session today, but I just want to give you a bug, infect you with a bug to actually go and see Synapse Analytics at some point in time. But anyway, our session is mostly about talking about machine learning and how to start with machine learning. So this is my cat that you saw just a few seconds ago, and this is usually me. I typically do a lot of different sessions which are very crazy, and I try to keep them crazy because, well, I'm crazy as well, so it's normal to do it. So let's start. Oh, it stopped. Okay, wrong film. This was supposed to be a different film, but anyway, this is mostly the theme should actually be 2001 and 2010, and most people probably already know who this nice entity is. It's something called HAL 9000, which was part of a film. And this is what's in the 60s, in the book in the 60s, then the film was considered the first, well, at least for fiction reasons, the first intelligent computer. Now, this session is not about making computers look intelligent. We have different things for that. I will give you a list for things that you can look at to make computers a bit more intelligent, but be careful because they might kill you. Some computers will eventually kill you. That's in all of the films. We know that this is going to happen. So please be careful. Just use machine learning normally to handle your data, to handle, processing images, processing whatever you want. But be careful. If the machines take over, we're going to be the first victims. Anyway, this is me. This photo was actually taken yesterday. Yesterday. So anything from me, you can go to andy.pt, and somewhere there you have links to all of the places, etc. And I have a link that's a link to all of my sessions, so you can go there and actually see all of my content. I am improving it, so it's in a temporary website. I am improving it. I've said that for 1,000 years, but hopefully at some point in time in the future it will be done. But currently it does have some of the more recent things. Anyway, let's divide this session into two parts. The first part is just to talk about what machine learning is, and the second part is to show you how you can use machine learning. So based on the information that we talked about, how you can use machine learning using Azure, but in whatever I'm going to say, you can use it somewhere else. It doesn't have to be Azure. It doesn't have to be a Microsoft product. You can just use it anywhere. Okay, so first things first, we need to understand where machine learning, where artificial intelligence is. And if you have your databases here, so obviously John just before me was talking about ETL, etc. So he was getting stuff from databases. Maybe you do some data mining, knowledge-driven design, etc. So you get stuff from here, and then you can take some of the information, and now we're going specifically into this area. You can take some of this information and use it for artificial intelligence, for machine learning, for other things which are very specific to the things that we're now going to talk about. Now, there's some overlap here, and the most important one I want to mention is the misconception that most people have about artificial intelligence and about machine learning. Artificial intelligence is a generic concept that just talks about a lot of different things. One of the things inside artificial intelligence is machine learning. So machine learning is just algorithms. So if you are a developer, you'll understand this very well. It's an algorithm. In most cases, it might not be deterministic. So the same result that you get in might not be the same as you get out, but statistically, it will be similar in terms of, accuracy between them. If you compare them, it will be 1-2% difference when you process them 2 times in a row. And there's a lot of reasons to do this. Some algorithms are based on finishing certain things in a certain amount of time. If that fails, they will give up after a certain amount of time because they process this, they process that. They don't seem to improve after a certain amount of time, so they will stop it. They don't see improvements. And because not all machines are running exactly the same way, the results might be slightly different. Statistically, they will be the same. Okay, artificial intelligence has much more things. So if you consider that you have self-driving robots or bots or cars or something, that's a different area of artificial intelligence. Machine learning receives information, processes the information. So basically, it's almost like an intelligent ETL, and then provides you with knowledge, which you can use to ask things, and provides you with knowledge so that you can use it to drive the robots or something else. But that's a different AI area somewhere on the side. Okay, there's obviously much more. One of the things I wanted to mention is, if you want to learn machine learning, you should know the basics of statistics, the basics of mathematics. But consider this: you don't have to be a PhD in statistics or mathematics to know machine learning. If you are the one designing the algorithms, well, maybe yes. But in most cases, you are consuming the algorithms. So as a developer, you know how to do this. You have a class of something, and then you're going to use that class to do something, right? So you have SDKs, you have other things. You're just going to use them in those specific logic. So that's the easy part, of course, right? Now, what actually happens here is that in terms of statistics, in terms of maths, what I would recommend is that you have at least the high school equivalent of maths. It's usually enough for you to consume basic things in machine learning. If you want to be a data scientist, which is a bit more advanced, in that case, I would recommend learning a bit more about machine learning. There's a lot of books that talk about statistics, that talk about mathematics, but specifically for machine learning. I'm not going to recommend anything specifically. My recommendation would be, nowadays there's a lot of things online which are even free. So just start with those, get acquainted with those, and if you feel you need to learn a bit more, just have a look at some. I'm not the worst biggest expert in machine learning, but a lot of people recommend this book, that book, etc. Just go into those books secondly, okay? But first, try the simpler things, because in most cases for you as a developer will be more than enough. Now, I don't want to go into the details, technical details of some of these algorithms, but there are two divisions of algorithms. You have the supervised algorithms. So let's say you have a table, and that table has a lot of information. Let's say it's a bank loan. So that bank loan has information, each line is a bank loan. So person, age of the person, or date of birth of the person, this can be the thing. So you can have things like the date of the bank loan, but that's not interesting for you. The interesting part for you is not the birthday of the person. It's the age of the person when they ask for the bank loan. Let me give you a specific example on that. So let's say you go to a shop and you buy something in the year 2000. Okay, and let's say you were born in 1950, so that means you are 50 years old, and you buy something 20 years ago. Nowadays, and I still consider that we are in the year 2020 or something like that, because the pandemic freezes time for everyone. So 20 years later, someone else who was also born in 1950 buys the exact same products. Now, machine learning can do a lot of different correlations, etc. There's a lot of interesting things, so association, clustering, etc. But if you want to compare these two people that bought something 20 years ago and something now, so the same product, these are completely different people, because when they bought the product, and that's the most important thing, it's not their age, at least not in most cases, it's not their age, is that one of them bought the product at 50 years old, the other one bought the product at 70 years old. And those are completely different age groups. Okay, and if they are different age groups, that does not correlate with each other. These are probably completely different events. Okay, now let's say you take one of those tables, and the table has a lot of information. Let's go back to the bank loan. A lot of information about the bank loan, where you work, how much money you make, how much money you have in the bank, the usual things. And then in the end, it has just a yes, no. It can be a 0 or a 1, a yes or a no, whatever you want, A, B, something, okay? So it has just a field that tells you if you paid the bank loan, yes or no. True or false, something like that, just something very simple. Now, based on that, you can do machine learning. So 1 minute. Again, I have my cat, because as soon as my cat sees machine learning or anything Azure, she will start to meow and want to interact. So she's just here in my lap to be calm. Okay. So in space, they don't have cats. They should. But anyway, let's say that you have the result column. When you do the training itself, what you're actually doing is that you are asking the training to confirm if when you run the training, the results will be correct or not. And then based on the results of the training, you'll have a percentage, which is how things are running. So let's say if the percentage, let's say the accuracy, there's other metrics, but let's use the accuracy. It's like a quality metric. So let's say if the accuracy is 90%, that means 90% of the time, based on the information that you had, when you do predictions to see if the person will pay the bank loan. So if someone is asking for a bank loan in the future, in that case, 90% of the time, the result will be correct. But in the case of a bank loan, because it's a long-term thing, it might take 30 years, 40 years. Sometimes this is not perfect. You based on the information that you can do, it's not going to be perfect. But anyway, those, because you already have the answer, the possible answers, and learn from something that already has answers, that's called supervised. And supervised might be something different. So you have no expectations of what the result is going to be. You just want to do some processing so that you understand what's happening. You can do clustering, association, etc. An example of this is the shopping part. So you want to correlate people when they do shopping for this product, for that product. You want to correlate age, you want to correlate everything, and you want to understand what's happening, but you have no idea what to expect. So that would be unsupervised. And they have different techniques like cross-validation and things like that to actually make sure that the results are good. But that's a different story. That's a bit more advanced that we want today. There's also reinforcement learning. So one of the things, besides this, one of the things you can also do is one of the expectations. So no matter what the algorithm is going to be, what type of algorithm, etc., one of the things you can expect is 3 months from now, 6 months from now, whatever the time frame, it makes sense for you to retrain your algorithm. Okay, so that thing will always happen as well. Now, going back to supervised, unsupervised, etc., we have a few examples. So regression, classification, and clustering. I have a few examples next to this. Neural networks are a technique that you use in which you define infrastructure somewhere in your CPU, in your computer, in memory, etc., where you actually learn similar ways that you learn for the brain. Now, neural networks, there's algorithms for regression, for classification, for not so much clustering, but for regression classification, there's algorithms that actually use neural networks. So the concept here can actually be used in multiple different usages. Now, consider this. Neural networks is supposed to be the best one, but it also takes much longer. Okay, whatever usage you're going to do, for instance, you can do regression or classification using neural networks, but that might take a long time. So you have to be careful because you might just want something simple, and then neural networks will be very precise, will be very good, but it will also take you a long time. And in this case, if you have to pay more money, and specifically in Bangladesh, you have to pay more takas. Is it takas in plural? So that's going to be very expensive. But anyway, let's have a look at some of these algorithms to understand quickly how these work. Okay. By the way, I hope this doesn't insult anyone, but let's say that you are an alien coming into Earth and looking at this, and from a statistics point of view, this is true on average because there's almost similar number of men and women, a bit more women than men. You have, let's say, 0.99999 something of this, right? The problem is that this makes no sense. You either have 2 or you have 0 or something in the middle. Let's assume. But from a point of view of statistics, the average is 1, and that's wrong. So from a machine learning's point of view, this will be a problem. Okay, this will be a problem. So I saw this online somewhere. I had to include this in the presentation because this is the most obvious one. Although hopefully this doesn't insult anyone in that case. Now let's get to linear regression. If you go to high school, and actually very early in high school, you have something called linear regression, and typically you put some dots on it. So let's say they give you 2 or 3, well, let's say 10. They give you 10 points and you map the 10 points, and the rule is you have to create a line that goes from that tries to go around all of the points, so to be as close to the points as possible. There is a more formal mathematical definition. I'm not going to go into that. It's also simple, but typically when you were in high school you try to draw a line, and then that line has some characteristics. Now, how does this work? Well, let's say you have a lot of points here, and this can be anything you want. So these can be temperature, this can be other things. Doesn't really matter, to be honest. But because you have all of the events happening here, all of the situations happening here, you draw a line, and this is the most accurate line between all of this. Let's say on average. Okay, keep it simple, on average. So what can you use to predict this? Well, you can predict very simple things. So simple trends of what's to expect. You can predict things like weather, economics, etc. Although, to be honest, some of these will use a bit more complex scenarios. The best thing about linear regression is that it's extremely simple to calculate and very fast. The other one will be extremely slow. Okay, but there's other things. Um, so you have things like vector machine, etc., in which you actually get not a straight line, but a curvy line that tries to go around the points, and that might be a bit better. So you can choose the algorithms. I'll show you some of the algorithms just in a second, but in any case, the idea is exactly that. So you choose the best algorithm for this. This one is very simple. Now, once you do some ETL and then you do some training, the result of this will be something called a model. And that model is just a very small file. Let's say you start with 1 petabyte of data, so a lot of data, and then you end up with just a few kilobytes of model. In this case, specific for linear regression, this is probably the only one where you look at the things and you can understand what the variables that are inside that model actually mean. So one of the variables is the distance from the point 0 to the point, let's say, 25. I'm assuming this is close to 25. So that would be the distance, the distance at the axis. You also have another variable, which is the inclination of the curve. So you have something like A plus bx, right? So if you know A, which is this vertical distance, and if you know the B, which is the inclination of the curve, if you get the x, so let's say x will be one of these at the bottom, you get the y immediately. So all you have to do for that model is to have two values. One is A, one is B. And that's the simplest one you can understand. All of the other ones are very confusing to understand because those values are completely crazy. But this one is very simple to understand in terms of concepts. Now let's go for the next one. And the next one is something called linear regression. But before that, let me just say, so similar as the one before, if you take your data and try to use a lot of different algorithms to try to extract data that might not be there, you might end up with something like this, okay? And this is actually true. This is one of the problems, one of the fallacies with machine learning. You want so much for the data to be there that you can actually use some algorithm that gives you that results, and then it will be skewed and it will be a different data, okay? So it's very important for you to know your data, to know what to expect, okay? And then the algorithms will probably generate something that might be unexpected. So you shouldn't say that they are wrong. You should analyze before you determine that there's something wrong and come up with a different algorithm to fit your mentality of what you expect, okay? Because the result might be different, okay? But anyway, let's go for logistic regression. I have a very big cat here. I'm going to try to get rid of my cats because it's very difficult to do a session with a cat in my lap. Especially, you know, people in the 2001 film never had this problem with a cat next to them. But anyway, let's talk about logistic regression. Let's say that you have two possibilities. We talked about the bank loan, yes or no. So that would be a two-class model, okay? So yes or no, true or false, A or B. So it's always two. Well, this is okay. You also have three-class model, four-class model, etc., or multi-class model, as we usually say in general. There's good algorithms. Logistic regression is one of them, where you can use this for two-class models, and it's specialized, gives you very good results. There's other algorithms which are very specialized for multi-class models. So that means that they require that they are much better at determining multi classes, so three or more. However, if you use that one to determine two, it's also good, but maybe not as good as this one. Okay. Now, let me take a different example. Let's say you are in school. This is about some kind of birds, African birds, European bird, and they compare the speed, etc. But let's do something slightly different that we can understand. If you go to university or high school, something like that, you have exams. And when you take an exam, you either study a lot. Let's say that this 1.5, 3.5 would be the number of hours that you study for the exam. Let's say it's that little, okay? So if you didn't study anything, the most likelihood is that you are in the lower category, which is you didn't study, you failed the exam, okay? So let's say that this triangle, blue triangle here is you failed the exam. Okay, if you studied a lot, the likelihood is that you're going to pass the exam, so that will be okay. However, even if you study a lot, you might still fail the exam. Even if you don't study anything, you might still pass the exam. Okay, so that can happen. However, how does this work? Well, based on this information, logistic and others, not just one, but typically multiple fields, they will try to analyze what's the likelihood of you passing the exam. Okay, now the average of this, the 50% average of this in this case, would probably be close to this dot here. It's not a vertical dot, it's actually horizontal, because this would be 100%, this would be 0%, something like that. Also, these values here are not at the bottom or at the top. These are a percentage that show up somewhere in the middle, but then you have to define something called a threshold. This would be a horizontal line here somewhere, let's say close to here, that you define that below this point I'm going to predict as negative. On top of this point, I'm going to predict as positive or pass or something like that. So when you do the prediction, you adjust based on the data. Sometimes it's not 50%. Sometimes it makes sense to be 60%, 40%, whatever the value is, because it depends on your data. Every data is different. There is no rule for this. You have to analyze based on your data. So when you have all of the scenarios, Okay. Hello. Okay. Oh, no problem. Okay. No, but this is all right. So because I'm actually hearing Bengali speaking, right? So this is very positive. It can't just be English. Anyway, but don't worry. This is what happens in the last 2 years. All of the events, these are very confusing. The most typical one is something called, "Is my camera on? Can you hear me?" So this is okay. Oh, I cannot hear you.
Sorry, Andrew, for interruption. Your slide is
That's
not
okay.
visible actually.
My slides are not visible. Okay, so I'll unshare and share again. This is very strange. Okay, sometimes this kind of thing happens, but let's see. Is it visible now? I've just shared again. Okay. So but I am visible here, right? In terms of
visible, and
video.
I thought
Okay.
that you are just talking.
Okay.
You don't have any slide to view.
Oh no. So I am indeed sharing. Is it showing up as black or something like that?
Right, it's the black screen.
Oh, I know what the problem is. Oh, I'm sorry. I know what the problem is. I think I have an answer for that. I do apologize for this being strange, but I do have an answer for that, and it's a bug somewhere in Teams that honestly I cannot really understand. But give me a second, so I will try to solve this problem. That is okay. So give me just a second. I will try to solve this problem and join on Teams again. So give me just a second. Meeting info, copy join info. So I will try to join on Teams and okay. But this is very strange. Sometimes Teams has a bug for sharing the screen. Something that I honestly cannot understand why. But give me a second. Let me just see if I can join. Okay, on the page. Okay, this is very strange. And for some people, Teams, at least once you use Windows 11, for some strange reason, it stops working. It stops working for a lot of people. So give me just a second. Let me just find the link that you sent me, and I will try to join via 1 second. 1 second. I will try to join via the browser, because there is a bug which I honestly cannot understand why. There was a bug that does not allow that gives you an error while trying to share things. Don't ask me exactly why, but give me a second. So I will obviously share. Give me a second. Okay, so where's the thing? Give me a second. So copy link. I will try to share this here. Let's see if this is okay. Continue on this browser. I will try to share it. I do apologize for this. Okay, so I will try to speed up with this. Okay, so anyway, join now. So I will try to join as a secondary screen. Give me a second. Okay, so I will. Okay. So mute. Okay, so I will share this with my browser. I have had this problem before. It's some kind of bug with the Windows 11 and Teams. Sometimes it works, sometimes it doesn't. I honestly cannot understand why, but I've seen more people have this problem. Okay, so hopefully you are able to see this now, if that's okay.
No, right. It's okay. We can view your screen. Your skin is visible right now.
Okay, so it is visible now. Okay, so finally, okay, so we were talking about linear regression. Let me quickly repeat. So basically, you have a line. The line will have certain inclination to acquire all of the points as close as possible, and then you have a distance from the line at the origin, and you also have an inclination. This will be a plus bx. and you can calculate, if you get the X, you can calculate the Y, so that's easy enough. That's linear regression. You also have another one, which I was going to mention. So the torture part, let me just mention the torture part. If you try to torture the data, it will confess something different. So this will be something that might actually happen. And we were going for logistic regression when you mentioned this. Sometimes this happens. It's perfectly okay. I will share the slides later. So if anything is missing in the beginning, I will definitely share the slides. It's not going to be a problem. But anyway, I was mentioning this. So if you are, let's say, here at the bottom, you might have some negative values and some positive values for the exam that I was mentioning, for instance, or for the bank loan or for something like that. In this case, this might not be the best example because the concentration is very strange. But in any case, let's say that you try to take the exam, you study a lot for the exam, let's say 3 hours, and then you still fail. Or if you don't study anything and then you still pass. So it happens. But one of the things that will happen is that these triangles will not be here at the bottom or at the top. They will actually be vertically in the y-axis, let's say from 0% to 100%. So 0% will be A and 100% will be B. This can be true, false, etc. This can be yes or no. It's two classes, so two classes can be anything. Plus, one very important thing to mention: the true class does not need to be the 100%. And the false class does not need to be the 0%. It can be the other way around. So the true one can be the 0%, and the false one can be the false one can be the 100%, and the true one can be the 0%. It depends greatly on how the training is done. Okay, so you have to be careful to make sure that you analyze things properly and don't confuse the yes with the no and vice versa. Okay, but anyway, this is usually a percentage. Okay, and as I mentioned, there's usually something called a threshold, which, let's say on average you start with 50%, and then you can decide that it makes sense for the accuracy to put it at 60%, 70%, 30%, 40, etc., because of the data that you have, which is slightly different. Okay, so anyway, besides this, you have many other algorithms related to this kind of concept. So remember, linear regression and regression in general refer to things like you have a line, which can be a linear line, so a straight line, or any other kind of vector machine that has different lines of function for different style of lines. Or you can also have logistic regression, in which you have two classes, true or false, or A or B, or something like that. You can also have multi-class, but I'll show you some algorithms of that just in a second. But you can also have other different things. One of them is, and this one can be used for regression. This can be used for classification, etc. This is something called a decision tree. This is how machines can learn. So let's say that there was actually a game called, I'll show you this in the next slides. 1 second. This is called 20q.net, which is a game where they start asking you questions, and then they will construct a tree based on your questions, and they will try to give you an answer. Now, this would be a tree similar to this. So you start with some way to classify people, and this can be a classification, but you are using something called a decision tree. So based on the information you are receiving from the users, this can be tables and things, or this can be interactive. It's whatever you want. You can say, let's say the first question is, and by the way, this, you can put this into a table. I've actually created this kind of algorithm like 20 years ago. You can create the algorithm so that this can learn very quickly. I've created this like 20 years ago in Access with a simple table and maybe 20 lines of code. This is very easy to create. So let's say that the first question is it a mammal? So if it is yes, you go left. If it is no, you go right. This can be replaced by simple, lines in a table. It's not really a problem. So if you say yes, in that case, do you use it as a pet? So yes, well, I'm thinking about a cat, let's say, but they consider that this is a hamster. Okay, so if you say no, is it a farm animal? So if it's yes, it's a goat. Okay, if it's no, might be an elephant. Okay. So anyway, let's say that I'm assuming my cats. So people keep it as a pet, so it's a hamster. So from a computer's point of view, if you win the tree, it's a hamster. Okay, it's not true. It has 4 legs, it has a tail and things like that, but it's not true. So the question is, and the computer will tell you it's a hamster, and you say no, this is not true. So the computer will say, okay, what's the difference between a hamster and a cat? You can just say, well, the cat has whiskers. Well, actually, the hamster as well. Everyone has whiskers for some reason. So let's say that the cat meows. Okay, this is a good technique. Does it? So they will. The computer will add an additional question here, which is, does it meow? Yes or no. So if it's a yes, it's a cat. If it's a no, it's a hamster. But let's say now you have a dog. Does it meow? No. So they say it's a hamster. No, 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 it's a dog. And then you say, okay, so computer will ask you, what's the difference between a dog and a hamster? Well, the dog barks. Okay, and then you ask another question, does it bark? Yes or no? So you construct questions gradually, and you can have limits on these trees. So you can have limits on the number of total nodes in the tree. You can have a limit on the number of levels on the tree, so horizontal levels on the tree. You can have multiple trees, because remember, if you are doing decision tree, you can have multiple levels on a tree. Okay, let's go for the next one, and I'll explain this game very quickly. You can go to 20q.net. They started saying that you only had to answer 20 questions and they will get it right. Last time I tried this a few months ago, it was up to 32 questions or something, because they acquired so much information. They have so many trees inside, then they will not be able to determine the answer based just on that. They will try to guess after 20 something questions, but they will say, well, I can ask more questions and refine the answer. Am I close? Yes or no, etc. So the answers here are simple things like yes or no. Unknown, this will be equivalent to I don't know. So we ignore that question from the point of view of the tree. Irrelevant, that would be a null, so not applicable to us. This is not part of our tree. This is someone else's tree. And then sometimes, maybe, probably, doubtful, usually, depends, rarely, partial. That would mean that instead of just going to the left or to the right to the yes or the no, you can actually assign percentages of accuracy based on, does this go to this one? Well, probably, but with 80% certainty, not exactly the same. So some of these maybe sometimes might be 50%, maybe might be 50%, but probably might be 70%, etc. So you can actually adjust the tree instead of just saying yes or no to the left or to the right. You can adjust it with some percentages of reliability on the answers of the questions. Okay, so there's a lot of tricks that you can do with this. Okay. Um, Now, in the end, if you know SQL and if you know SQL joins, think about these kind of trees as you get a result. So you answer all of the questions and then you get the last result in this tree. But you also get the last results in a different tree and in another different tree, etc. Because you ask to analyze all of the multiple trees and answer questions on multiple trees. In the end, you can do what, it's not the correct way to say this, but think about this as a SQL query. You need to do a join on the result of this tree with a join on the result of the other trees. Okay, so this is, it's not the way that it's done, but it's the concept is similar. Okay, so when you join everything together, you might get a result which might be the most expected results, and then the result will be a percentage of all of these things. Okay, so whatever option you decide to do, they will give you, oh, there's a likelihood of 80% that the answer is this. Maybe it's a cat or something like that. Oh, sorry. Maybe it's a cat. Am I guessing it's a cat? So right, wrong, or close. Okay. So close can be an option instead of right or wrong. So if it's wrong, it's just different. If it's close, well, maybe I'm in the right set of trees. I'm in the right set of 2 or 3 trees around, but maybe it's something similar. So I'll ask a few more questions. Okay. So decision trees are actually used in all of these models, like regression, like classification, mostly classification, but they are used in a lot of different things because they are an easy way for you to detect things, especially if you have things like questions, like, did you pay the bank loan? The result's going to be yes or no, but then you have things like, what's your job? And your job is not a number. It's going to be, oh, I work in IT, or I work in McDonald's or something like that. So those will be not transformed into numbers, but those will be questions. Do you work in the food industry? So McDonald's, Pizza Hut, whatever that is. Do you work in IT? So are you a developer, etc., etc. So they can fill the tree with detailed questions. Okay, I also want to talk about one last algorithm just to give you an idea. One of them is called clustering. So you have algorithms for you to understand what's happening with things. So this can be clustering, association, etc. In the case of clustering, there's one typical algorithm which is older than me. It's somewhere from the 70s, which is called k-means. Now, this algorithm was changed over the years to include some optimizations. Now it's much more optimized than the 70s, but still the concept is the same. So let's say that you have one metric here and you have another metric here. You can have three metrics if you want and be three-dimensional if this is something that you want, or fourth-dimensional, etc. So instead of making a circle like you see here, you make a sphere or something like that. So the idea here is to aggregate inside of these spheres, is to aggregate what they call clusters, okay? So you aggregate similar situations. Now, if you go to a supermarket, people who buy wine also buy something, cheese or something like that. People who buy bread also buy something else. Exception, people who buy toilet paper, they are desperate because of the pandemic. That's an exception. If you go for those normal things like toilet paper, like other things like that, there might be no correlation whatsoever. It's just something that after a few months you need to buy it, but it might not be related, toilet paper might not be related to buying wine or buying something else. Maybe you go there once a month and you buy everything once a month. So every time you buy wine, you buy toilet paper, and you might think that they are correlated, but they are not, because simply this is just the time of the once a month or something that you go and buy the most amount of shopping, and the other times you just go there and buy bread or something like that. So might not have actual relationship. So it might not be a need, a thing that you need relationship. It might be a thing that's it's convenient relationship. So it's a different kind of relationship, or no relationship whatsoever. It can also happen. You're buying toilet paper for someone else who's at home with COVID or something. This happens. Okay, this is perfectly normal. So how does this work? Let's say you have one metric on the bottom on the x-axis and one metric on the y-axis. Okay, so let's say that's average households power consumption and then peak household something. So one person is going to be here, another one here, another one here. So there's clusters here, whatever they mean, that people who buy this also buy that or something like that. So you aggregate into some things. And when you aggregate, you know that these people have the same thing as the other people. Okay, so you can suggest if this person bought something, you can suggest the same thing to the other person. It might work. Now, this can go terribly wrong. One of the examples of this is there was a story probably in the United States, but I can't guarantee, that someone started to receive from the supermarkets suggestions about buying baby stuff, baby bottles and I don't know, diapers or something like that. And the person was didn't know what happened. And a few months later, she discovered she was pregnant. Okay, so she sued the supermarkets, very, very typical sometimes. She sued the supermarket because the supermarket was infringing on her, let's say, privacy or something like that. In reality, well, I can understand the problem. Of course, this is a sensitive area, but in reality, the computer was just following the example. So this person did not know that she was pregnant. So she was buying things that she wanted. She went to places, oh, I want to buy this. And other people were also pregnant at the same time or something, were buying the same thing. So they were put in the same cluster. And suddenly the bot understood that those people, after a while, started to buy something. And they correlated that into that person, but that person was very upset. So there's also a scenario here about privacy, about privacy intrusion, etc., that can go into this. But in reality, the algorithm is kind of blind, because the algorithm has no idea that person is blind, just recommends based on metrics and things like that. Okay, so it's impossible to avoid this kind of problems. Anyway, how does k-mean work? Well, it's very simple. You start with putting centers or centroids in, so 2 or 3 dots, in this case 5, okay, one for each circle, and then these dots will try to get the closest So for each item like this, you will try to associate it with the closest possible center of this thing. And then based on that, yeah, this is the first step. So all of these will be classified as, let's say, A, B, C, D, E, so 5 in total. And then once you do that, you move the center to the average of all of the results that you get for all of these. And then you try to determine the distance between all of them again. And then you move, some of these might move, let's say, from this one, to the left, and so on. So it might move a bit. And after a few iterations, let's say 4, 5, 10, whatever the number, nothing is going to change. After a while, things stop changing because that means that they are in the right place. That's the k-means algorithm. Very simple to implement. It's not difficult, okay? Nowadays, they optimize it so that they have less iterations, etc., because you might be handling, gigabytes of data, petabytes of data even. So that means you need to optimize this a bit faster. Okay. Now, remember one thing. If your result is 100% correct, you're not doing AI, you're not doing machine learning, you're probably doing ifs or SQL where clauses. So it's going to be different. Okay. Anyway, this ML cheat sheet, I'll actually post the link here just in case. Okay. So the link here, but in any case, if you are watching this video later on, this will still be similar. Okay, so you go to aka.ms. So this one that you see here in the bottom, ML cheat sheets that you see here in the bottom. I put the link on Teams just in case, but basically what you have here is very simple. So let's say you want to predict 2 categories. So you start here, of course, 2 categories. So 2-class classification. You have support vector machine. So I talked about this. These are mostly for analyzing all of the things close to the curves. You can do 2-class something, and as soon as you see 2-class something, that means it's a 2-class classification. You get a result of yes or no, A or B, something like that. But you can use logistic regression. So we talked about this. You can also use decision trees, decision forests, etc. You can name it whatever you want, tree related. There's trees, forests, jungles, whatever. Anyway, you can also use neural network for this. So basically you want to get to 2-class, but you are using a neural network algorithm, which is very optimized. Anyway, for multi-class, you can use slightly different ones. So multi-class logistic regression, etc. So some of these are more optimized for A, B, C, or D, as they say here. This would be just for A and B. Image classification, you also have a few of them. Most of these will use neural networks. When you handle images, neural networks is the ideal scenario. You also have things like some recommenders. You have things like clustering. So k-means is clustering. There is 1 or 2 more, but 99% of the times you use k-means. You want to predict values, so temperature values, things like that. You use regression, so use any of these. So linear regression, Poisson regression, and then you have Bayesian regression. This is actually very good. The things that you see here are important. So linear model, that means that if you have more data, the amount of memory that you need to use will grow with the amount of data. If you have 1 gigabyte, let's say you spend 1 gigabyte of data, you spend, I don't know, 500 megabytes of RAM, let's call it like that. However, if you have 2 gigabytes of data, that means you use twice as memory, so 1 gigabyte of memory, okay? So it's linear in terms of growth. Some of them are not linear. Some of them will go exponential, and that's a problem. Some of these, you have to read what's here as a help, because they will tell you what's the best one. So accurate, and then long training times, fast training times, and then large memory footprint. This is going to be terrible. Okay, so this is mostly the problem. Anyway, text analytics, you have a few more, etc. But all of these, just read from the details what to expect. You can actually replace one with another, so this is perfectly okay. So let's actually move on. So a few months ago, 1 year ago, you had a lot of monoliths. So all of these, they showed up somewhere else. And because this is the 2001 one, let me just say that in the United States, this monolith is typical. Here in Portugal, this kind of monolith to get you a shower is also very typical as well. But anyway, let's go to the Microsoft world and see what we have. So you don't need, as I mentioned, you don't need to be a data scientist to play around with it. Okay, so how does machine learning work? So let's say you get, first part is the ETL, you get your data sets, and this is the same as the session before. You get your data sets, you clean them up, you prep them. Let's say prepping, an example of prepping, feature engineering, etc. Let's say an example of this is you have a data birth. That's not right. You want to subtract the date of birth from the date of the events and then see the age of the person during that time, because you want to get the age. And then you aggregate ages by age groups. So let's say every 10 years, so from up until 18 years old, that's one age group. So that's kids. Up to 25, that would be university, etc. 25 to 35, 35 to 45, and so on, over 65, etc. So you can separate this into different groups. So let's say group A, B, C, D, etc. So you separate them into groups so that it's easier to aggregate them and say that these are probably common. Okay. Anyway, then you do the training, so you can use any of the things you want. So regression for a value, a continuous value that you want to detect, temperature, you want to detect something like that. Classification, so two-class, multi-class. Clustering, you can also do anomaly detection, although some of these algorithms for anomaly detection, you can use the normal algorithms and get the results, but there are specific algorithms for anomaly detection. Okay, if your objective is not to get the normal values and then also find anomalies, your objective is okay. So can you hear me? So something very strange happened. So my computer crashed with the blue screen of death.
No, it's okay.
So this happens. So just give me 1 minute. I'll show you a few more slides.
Okay.
Because of the lateness of the hour, we might not have time to actually see the demos. Okay, but unless you tell me that we can do a bit more time, but let me just start the screen and join again in a different in 1 minute. So the computer is just booting up, and then I'll show you some of the remaining slides just in case.
Sure, Andrew, sure.
I do apologize for this. This is actually not very
No,
typical.
it's okay.
You can see my kitchen from the back. I am on my phone, but this,
Right.
so let me just do this. So I'll set the phone at this moment, and then I will try to get back to my PowerPoint. Okay, but the good thing is that we are using Teams, and because we are using Teams, I am able to join via the phone and say something went wrong. So this okay. So give me a second. I will join this immediately on Teams. It's just a few seconds to join. So Teams is actually opening up. You know, this takes a long time. So let me just say restore.
It's okay, Andrew. No problem.
So I think the best way is I'll show you just a few slides at this moment. And then in terms of demos, I do have some pre-recorded demos that I have in the last few months, etc. So maybe the best option is for everyone to oh, so sorry. A second. 1 second. This is very strange. So mute. Okay. So give me a second.
No problem, Andrew.
So this
Also,
I have
also we can arrange a part two session for next month, say for user including demos and others things that you want to show. And
this will be maybe just to finish. I think that the best way is to just show you 2 more slides. I think that would be the best.
Take time.
So, I'm joining now. Hopefully this. Okay, so so let's say speakers. So hopefully I am. Can you hear me now again? Is this okay?
Yes.
Okay, so give me just a second. I will join again on this. I do apologize for not doing the demos. I actually spent some time preparing these demos for showing in Azure. So it takes a few hours to prepare them and to start them, etc. But let me just join on Teams at this moment. So let me just share my screen. 1 second, please. Let me just share my screen. So restore. So I am on Teams. Give me a second. Teams, Microsoft.com. So I'm just joining now. Give me just a second, because I do apologize. This sometimes happens. I'm using Windows 11, and Windows 11 seems to be having a lot of bugs, really a lot of bugs. And Teams, hopefully the new version of Teams will be a bit better. But so far, I'm not seeing any real or nice improvements. So I'm joining now to share the screen as well. Okay, so join now. Okay, so I'm joining just to share the screen, and let's see 1 or 2 more slides, and then we'll be okay. So anyway, desktop window, share it, screen 2, share screen 2, share. So hopefully this will be okay. 1 second, my phone is already saying stuff. Okay, so I think I was here when this crashed completely. Sadly, in the video, you probably don't see the green screen of that. I'm actually using Insider Build, so it's a green screen. But but in any case, let me explain the concept here. So preparation, as I was saying, might be something that you get when you change, let's say, birth dates into actual age or something like that. So this makes perfect sense. In the meantime, you do any kind of changes that make sense. You group people by any kind of aggregation, anything like that, which is okay. And then after that is done, I've just changed my background for this as well. After that is done, you do the actual training. So now the background corresponds to what I saw on the computer, except the smiley was negative. But anyway, then you do the actual training. This is fine. It might take a few hours, even months, in some cases, if it's a big training. Also, the cleaning might take you a long time because you have to specify what you want for cleaning. The cleaning itself is usually fast, but you have no idea what to expect. So the preparation part in terms of human work might take even more time than the training, because you have to adjust things because they didn't work okay. You have to adjust things, etc. So training might take a few minutes, a few hours, a few days even, and then you do some scoring and testing. So what is this? Well, let's go here. So you start with something, you change something, you split the data because you just want certain amounts of data. You normalize the data, so that's the cleaning, etc. And then you split the data into typically 2 parts. So on the left, you have the data that you use for training. On the right, you have the data that you use for testing. There was a bit more, but I don't want to go into this one. And then you have, let's say, the algorithm that you want to use, and then you point it to this one is tune hyperparameter, so it's a bit more advanced. But typically here is you'd have something that says train model. Okay, it's just a box that says train model. So you'd receive the algorithm plus all of the configuration in the algorithm. You would also receive the data just for training. And once that is done, that will generate your model. The model goes into here, and then the score model will try to predict things based on that model file. So a small amount of data variables, etc., that are used for predicting, and then that scoring is actually literally what you do here. So you try to predict things, and the testing part is getting the data for testing into here and trying to figure out the percentage. Let's say this can be a percentage or a different metric. Okay, let's say accuracy would be a percentage, root mean squared value would be a value which you want the shortest possible value, but the closest to 0 possible will be the best. Okay, so it depends on the metrics, on the algorithms that you use, etc. There's also something called hyperparameters, which is the configuration that you put here. So if you are using a decision tree, for instance, you adjust the number of leaves on the tree, the number of horizontal levels and things like that. Number of trees as well, so you can also adjust the number of trees. So there's a lot of things associated with this. Finally, last but not least, once you score the model, you compare it with the original values, and the evaluate box usually handles the comparison of this. Now, this one is graphical because in Azure Machine Learning, you can actually do graphical interface, but there's also code using Python, using R, etc. But you also have AutoML. So AutoML, you just get the data in, all of this is processed for you, just get results. Now, once you do that, and once you do the evaluation, you can actually create a separate one, which is a web service, a predictive web service, or you can use this as a batch. So you just have the file and then you use it once a day or something like that. But this one would be in real time. So you can use this in real time. Every time you want to predict if the person will be okay with the bank loan, you go to that web service, you enter the information for the person, and then you get the results. Okay, so and then you do retraining again and again and again as much as often. Now, this is probably the most important slide I wanted to show you about the Microsoft worlds. Okay, so you have something called Azure Machine Learning, which is the Azure Machine Learning Service or the Azure Machine Learning Workspace. There used to be something called Classic. It's not that one. Okay, now you have an SDK into this that actually allows you to run things from your computer or from the cloud or from anywhere else, but actually manage things. You have something called Hyperdrive, so you can use multiple trainings at the same time with different parameters. There's a model registry where you can store the information about the saved models so that you can use them again in the future and decide on the best one. So I have 3 or 4, I decide on the best one, and then I deploy the web service based on the best one. You can deploy the web services in containers, Azure Container Instances, Kubernetes, etc., or even deploy it yourself in a cell phone or in an IoT device or something like that. Now, this machine learning is probably the one you want to try. This is very simple to try, okay? But there's more. So there's Databricks, and Databricks uses something that we talked about before in the previous session, which is Spark. Okay, so Spark clusters usually use a lot of memory to handle these kind of things. So you can use Spark on Databricks. Databricks creates a layer on top of multiple Spark clusters that you can just create. HD Insights, you can also use Spark, but it's only one cluster. So it's a bit obsolete, not obsolete, but old. Nowadays, everyone uses either Databricks or the ideal Synapse Analytics, which would be the one that I would recommend. Okay, so but anyway, you also have HD Insight R Server if you want to use R Server, but Synapse Analytics is the one that has things like everything related to Spark, which you can use for machine learning, everything related to the Azure Data Factory. So you have a copy of Data Factory, you have a copy of not a copy, but you have the usage of using Power BI reports directly from there. So that's easy to develop everything in one go. You also have a data warehouse where you can store data, etc. So this is very practical. Plus you have links to Cosmos DB and now to SQL databases and things like that. Besides that, on premises or even in the cloud, you can install SQL Server 2016 or 17, 19, 2022. The most recent ones actually have an R and Python services, so ML services for both of these. I can tell you that from my experience in the last few years, people are moving away from R and just using Python. So my recommendation is use Python now. If you are starting up with machine learning, use Python, okay? Some typical libraries for Python are things like scikit-learn, PyTorch, TensorFlow, etc. TensorFlow is actually used in a lot of different languages altogether, even Node.js, etc. So it's actually very easy to use. Okay. So last but not least, if you use different things, you can even use ML.net, which is basically a library, because the trick of all of this is to use libraries. So all of this, Python is an ugly language, R is an ugly language, but it has amazing libraries. So ML.net, you can use .NET language if you know it, and then use the libraries for ML.net and solve your problem. And then besides the usual ML stuff, you also have cognitive services to do face recognition, but these are already done for you. You don't do any training. You just consume the services. You can have bots, you can have Power Virtual Agents, etc. These are all very easy. Now, most of these from the beginning, you will need to use something like notebooks. So these can be Jupyter notebooks, Zeppelin notebooks, mostly Jupyter, Databricks notebooks, etc. But you can use them directly there, or you can, do whatever you want. It's just easy. Okay. So having said that, I do apologize for running a bit out of time and not having time for demos. I do apologize for this. I would be happy to come back and do different demos if you want me to. But I know it's probably dinner time and you are hungry and things like that. But I'm not sure if anyone has any questions. But in any case, even if you're just seeing this video later on or something like that, I would be very happy to answer any questions just by send me a message. Just go to andy.pt, see any of my contacts in andy.pt, and you will be able to interact with me on social networks, so Facebook, Twitter, LinkedIn, whatever. Feel free to reach out, and I will be happy to answer any of the questions that you have. Okay, so in any case, thank you very much for being here. I do apologize for a lot of these technical errors. Most of these I can blame them on on Windows 11. But thank you very much for having me here. Thank you, everyone. Oh, wait a minute. Oh, we cannot hear you. We cannot hear you. You are muted.
Andrew, thank you very much. And actually, it's a fantastic session. And for the beginner, I think there is an option to take some few sessions so that we can be at expert level.
I would be happy to help, of course. By the way,
Actually,
let me just say that last week there was something called Global AI Bootcamp. This might be
yeah,
interesting for a lot of people watching this session. This year, I've actually hosted Global AI Bootcamp here in Lisbon. So we had a full day of sessions with people who actually came from different parts of Europe. So they actually came to Portugal. Others just did this remotely because of COVID. But we're going to have some videos. So these are not my videos. These are from everyone else. We're going to try to publish those videos so that people can see them as well. But in general, a lot of other people also had sessions all over the world, more than 60 locations. So if you want to see videos, this is a great time for you to see videos about Azure machine learning, about the Synapse Analytics, about all of these things. This is a perfect time. Just go and look for Global AI Bootcamp. Have a look at all of the videos that all of these people produced. We'll also make them available, eventually soon in a few weeks. Maybe at most we'll have to process them and make them available. But apart from that, just have a look at them. They are amazing. Last year, I also did a global AI bootcamp, specifically Global AI Bootcamp Singapore. If you go to andy.pt/doc, about a year ago, you actually have a workshop that I did to talk about Azure machine learning. There are some different things a year ago, but if you want to have a look at some of the demos, etc., this is a good place to start. I have 2 sessions on that event. Just go and see the videos. They will help you a bit, and they will, complement the things that I was not able to show today. But in any case, things change. So 1 year ago, things were slightly different. They have more things now. Nowadays, things will change. If I do another session in 1 month, another thing will change again. This will be completely different. So this is good and this is normal.
I know one thing. Can you share your links and slide? So if you share your
Yes,
links
of
or
course.
slide, then I will
So
share it to the event page and other meetup tweet, so that the audience will get the flavor. To
okay, so if you go to wendy.pt.
okay,
Oh, wait a minute, not HTTPS. HTTPS, this is always important, but the guy memorized without HTTPS. So if you go here, just click on this link. The address is really, really old, but just go on this link, and you actually have presented sessions, etc. I already have one or two this year, but I will need to update it. But at least last year, everything's done. And you have some videos here, so you can click on the video links. All of these videos are already available, mostly on YouTube, but they are available. Some of these have slides, scripts, etc., so they will be available. And give me until tomorrow or something like that, and I will try to add this to the list here as well with all of the slides, etc. The one I was mentioning is Global AI Bootcamp Singapore 1 year ago, so they actually had some. This video is about 3 hours. and it talks about some of these things. So it repeats some of the slides that you saw before. So I think that this will help in terms of demos. Things have changed, but not that much. So you can still understand the concepts. So this is a good one to see for about 3 hours and talks about a lot of different technologies. So all of that big slide that I've shown you talks about most of those technologies and gives you some demos, etc. So good one to get started. Okay.
Thank you very much, Andrew.
Okay.
Your session
Thank you very
is
much,
very much
everyone.
helpful for to get a start into the machine learning.
Okay, and thank you to you specifically for inviting me. Thank you very much. This was a very kind invitation, but also thank you to everyone that watched the session live, and especially also to thank you everyone who will watch the session recorded later on. Feel free to reach out at any time to andy.pt, and all of my contacts are there. So feel free to contact me at any time. Okay. So once again, thank you very much, and hope to see you soon. Thank you.
Thank you very much.
Thank you very much.
Thank you. Thank you very much for the audience. We are very much thankful to our speakers who have taken the sessions, and we expect that the sessions are very much helpful for your career and as well as your company. And we expect that the sessions will be bring you to the next step in context of machine learning or Azure Data Factory. And we expect you join this session, join our tech community session that is arranged in every month, and we are expecting that in next month we will going to arrange another event in 19th of February. And till now, thanks to everyone for attending the session. Thank you very much. Goodbye for today.